Hi, in this video we will talk about segmentation by clustering. When we talk about segmentation, we refer to create regions on an image. So it's natural to think about segmentation as clustering. We would like to represent an image in terms of cluster of pixels that belong together. The common recipe to perform segmentation as a clustering is to represent each pixel of the image as a feature vector that contains any relevant information about the pixel. The most common feature is the brightness, but we could instead use the color, for example. In this case, we could have the three components of RGB. We can also include the image coordinates. Additionally, we could use depth, either computed or if the camera already provides this value. The idea is that we can add any number of features that describe every pixel and use that to perform the clustering. Whether a particular combination of a feature vector and clustering method lead to a good result really depends on the application. There are many clustering algorithms that we can use. So let's start with one really basic, the agglomerative clustering, or clustering by merging. In this method, we will start by making each pixel its own cluster. Then we will merge the two clusters with the smaller intercluster distance. And we will repeat this until the segmentation is satisfactory. Let's see an example in 2 dimensions. Imagine that we have 6 pixels and their features in this 2-dimensional space are placed in this way. We can use the Euclidean distance to measure each point. So we start the algorithm and we merge the closest points. The point tree is closer to the cluster we just created compared to the distance of any other point to each other. So we merge it again. Then we recalculate the distance. Now, points 4 and 5 are the closest ones, so we merge them. We compute again, and now the point 6 will join 4 and 5. Finally, we could merge them all in one single cluster. This example raises good questions about clustering. First, what is a good distance metric? Again, it really depends on the application. We have seen in the class different distances, so depending on the data, we can use whatever we think is appropriate. The second question is about when we stop splitting, or in other words, how many clusters are there? It really depends on how many you want. This simple algorithm can be modified to only merge pixels that are contiguous on the image, hence preventing to create clusters with elements that are not connected in the image. A really popular algorithm for segmentations is Kmeans. In this case, we know in advance the number of clusters that we want, and the algorithm will do the rest. Imagine that we have these points and we want to find 3 clusters. We initiate the algorithm by randomly place 3 new points that I will call seeds. Then, for each point in the feature space, we calculate the distance between the point and the 3 seeds. We will tag the point to be member of the cluster of the closest seed, and we continue to the next point. We calculate the distance between this new point and the 3 seeds, and we make it member of the closest one. Then we repeat this process until we finish all the points. We now have 3 clusters, but we haven't finished. We will calculate the centroid of each cluster, and we will replace the seed of each cluster with the new centroid. And we will recompute the distance and membership of each point in the image. This process can take several iterations to converge. The convergence here means that the centroids do not change position compared to the previous iteration. Depending on the feature that you selected, K-means can also create clusters that are not connected. Usually, one way to avoid this problem is to include the image coordinates of each pixel in the feature vector. However, this will result in that large areas to be subdivided even when the color or intensity are similar because the pixels are far apart. Another method is called shift means and has the advantage that we don't need to define the number of clusters. The algorithm will find them automatically. But how it works? Shift means is based in the distribution of the features. So imagine that we have this feature map. Remember that it can be in a higher dimension. But for example, let's say that we only have 2 features per pixel. As you can see, there are areas in which the density is higher and others where the features are more dispersed. Then, the intuition behind mean shift is that those points that are highly dense are the centers of the clusters, and all the points around must belong to the closest one based on the distribution of the neighbors and not necessarily on the distance. Let's see how we compute it and then it will be clear. We have one point and we will create a window centering the point. Now we will calculate the mean of all the points within the window. This can also be the centroid. Now we know which is the mean within the window. We will shift our point to this new location. This is the reason why the algorithm is called shift means. We create a new window and then we calculate the centroid within the window again. And we repeat. As you can see, the distribution of the points is driving the position of the new mean. At some point, we will reach the mode of the cluster, and the window won't move anymore. So now we can assign our initial point to this cluster. Now we take another point and we repeat this whole process until we have assigned every point to a cluster. This algorithm can give really good results. However, it can be computationally expensive because we need to search the cluster mode for each point in the image. Hence, it can take some time in really large images. Okay, in this video we talk about how to use clustering to perform image segmentation. We review the agglomerative, K-means, and shift means algorithms. See you in the next video.